Okay. Take attendance before I forget. Today's the 2nd, isn't it? 2. It's kind of fun. Let's see here. So, absent, here, absent, here. All right. So today we're talking about an important topic, which is functions. We're talking about their graph, domain, and range. All right, but really, first of all, we're just talking about the definition of what is a function, right? And so your book says a function is a correspondence between a first set, called the domain, and a second set, called the range, such that each member of the domain corresponds to exactly one member of the range. I suppose that works. So we have, and so mathematicians like to use this notation. F is a mapping from one set to another. You can sort of picture it. I picture it like this. I think of A as like one thing. I think of B as another thing. And I think of F as like some kind of thing that transports me from A to B. That's how I think of a function. But for us in here, we're mostly going to, think of, func F given by, a formula, f of x. Or we'll think of given by graph, y equals f of x. So for the most part, and your book also has some kind of like little mapping pictures, like this is just for the warm-up of the idea. You can draw these little dot diagrams, like 1, 2, 3. Suppose you got 1, 2, and 3, and you want to think about a mapping to, 4 and 5. All right. You can draw some little arrow diagrams to illustrate possible functions, right? Like one function you could think about would be 1 goes to 1, 1 goes to 4, 2 goes to 4, and 3 goes to 5, right? So here we would have f of 1 equals to f of 2 equals to 4, and f of 3 equals to 5, right? The key idea here is that each input goes to just one output. So in this kind of picture, what you couldn't do, so this is fine, this is a function, right? Here's here's an example of not a function. Not a function, something like this. We could have 1, 2, 3. I'll put 4 and 5 over here again just to keep it the same. And maybe the rule is 1 goes to 4 and 1 goes to 5, and 2 goes to 5, 3 goes to 5, whatever. This would not be a function because 1 is not sent to just one thing, it's sent to two things, right? So it's not single valued, it's not a function. So let's talk about the graph. So definition, the graph of a function like f of x is the set x comma y such that x is in the domain. Well, let's just say this, such that y equals to f of x. And x in the domain of f. Now, f in the domain of f, that's just a fancy way of saying the formula for f of x makes sense. All right, so if we give a given formula, it may or may not make sense for different inputs, right? But anyway, the point is, if you have a graph, then the x and the y coordinates on the graph are related. So let's like look at an example here. If my graph looks like this, maybe I've got this point, let's say that that's 0, 3. This point over here, let's say that that is actually, I don't know, 6, 2. And over here, you got 10, I don't know, 5 maybe. Right, so, and we're given this y equals f of x, right? So my point to you guys here is I don't know what the formula is for the function, but I'm given this graph of the function. Well, from that graph, you can figure out certain values of the function, right? Like you can tell me f of 0 equals something, f of 6 equals something, f of 10 equals something. So we input the x value into the function, right? And we output the y value. So what's f of 0? 3, right? F of 6? 2. F of 10? 5. Okay, so you guys are bored. Good. Bored is a good place. I mean, I'm happy you're bored. Although that may be something you're learning in this class, and if it is, you probably should be coming to class. Let's see here. Now, so another picture people like to think about for the function is like this. You think about the function like a machine. It's a box, f, right? And its input, what you put into it is what? X. What comes out? F of x, right? It's a machine that changes x into f of x. This is what a function is, right? But the machine gets broke if you put the wrong kind of x into it, the machine breaks, right? So figuring out what kind of x's you're allowed to put in, that is the problem of finding the domain. Let me write it out in a sentence. The domain of f of x is equal to the set of all x which do not break the formula f of x. That's the way to look at the domain in terms of a formula. All right, so let's start by talking about that. There's another way in terms of thinking about the domain in terms of a graph. We'll come back to that, okay? Let's just start with this idea. So I'm going to give some formulas, and you tell me what breaks the formula. F of x, 1 over x minus 1. What number ruins this calculation? Like f of what doesn't make sense? What if we try to plug in x equal to 1, right? X equals to 1, yeah, gives division by 0, which is no allowed, right? So the domain of f here is going to be minus infinity to 1 unioned with 1 to infinity. That again. Yes, not that again. Hey, let's get nuts. Could get worse. F of x equal to 1 over x minus 2 plus 1 over x plus 3. Oh, no! See, now we got two troublemakers, right? 2 and minus 3 are both not allowed, right? So the domain of f should be x such that x is not equal to 2 or minus 3. You're like, that seems more fun to write. Okay, in interval notation, that's minus infinity to minus 3, right? And then union with minus 3 to 2, and then union with 2 to infinity. That's how to write that thing in interval. What? I mean, sure. If you want. Oh, you don't want that. That's not in the homework in chapter 2? I'm going to call the textbook. I'm going to call the author. I'm going to make a complaint. I'm going to forge lodge a formal complaint. Okay, fine. Let's. How about this? If this is on test 2, it's bonus. Yeah. So since you two are here, you're the only two that are going to get it, right? But listen, guys, like this, I know this is a pain. Like right above is a perfectly this you can do. And honestly, guys, even if you just write a sentence that says all x except when x equals to 2 or minus 3, that also works for me here. I shouldn't erase that. It's too late. Okay, so what's the other example 3? You could have something like f of x equal to the square root of 2x plus 1. Well, in this case, we need the square root. We need the input to be non-negative, right? So you'd need 2x plus 1 greater than or equal to 0, which is 2x greater than or equal to minus 1. So x is greater than or equal to minus 1/2. So in this case, the domain of f would be like, minus 1/2 included to infinity. So that would be the domain of this function. What's the graph of this function? Well, we can go back to the thing we did last class, right? We can plug in points, right? Make a table. You'll forgive me if I don't make the table. I'm just going to do it. So it starts at minus 1/2. Let's say that's here. What happens when we plug in 0? Plug in 0, you get f of 0 is what? Yeah. Is 1, right? So that's like here, right? And if we plug in, I don't know, like 3/2, what's f of 3/2? Well, I'm writing it out. I'm not trying to do it in my head either. Here you go. Cancel the 2's. You get 3 plus 1, square root of 4. That one you can do, right? 2, right. So f of 1.5 is 2, right? And if you use your imagination, you can see what this thing is doing. It's curving up like that, right? All right. So that's what the graph looks like. Now, if we can draw the graph, right, we can also determine what the range of the function is. Let me write out a sentence here for us. Range of f of x is equal to all outputs, of f of x, also known as the y values attained, or if you like the word attained, you could use the word reached in the graph. So when I look at this one, my example 3, what's the range? The range, well, it includes, I totally agree, so this point was 1/2, minus 1/2, right? Minus 1/2, comma 0. This point is 0, comma 1. This point is 1.5, comma 2. Yeah? So the range certainly contains 0, 1, and 2, totally agree, but it's got so much more than that, right? Because the range is supposed to be all values, right? So unfortunately, we're going to need to use that annoying interval notation again. What's that? Ooh, but it's never negative. Like this thing, right? That was minus. What? Sorry. The domain, well, the domain goes 0 to infinity. Thank you. If you already said that and I just like twisted your words in my mind. That does happen sometimes, right? Students will, well, there's two different things that happen. Sometimes students say the opposite of what they mean. And sometimes I hear the opposite of what you say. So either is possible. But yes, the range is 0 to infinity because it just keeps going and going and going, but it never gets below 0, right? So, but you see, figuring out the domain for a formula, that's relatively easy because you just have to figure out where the formula breaks. Figuring out the range, you really need the graph. And, you know, so that's kind of a pain. All right, so another example. If I have, so I'm starting here, let's say at minus 6 comma minus 2, all right? And then I go over here to, oh, I don't know, 10 comma 2, right? And the graph of my function looks like this, right? And this top point here is maybe 5 comma 3, right? And this, we're given y equals f of x. What's the domain and range of that? The domain of f. By the way, you got choices. You don't have to, you can just write f or you can write f of x. Either's acceptable. What did you say, minus 6 to 10. Now I'm going to ask you the harder question. Is it, but the domain, is this, those are the allowed x values for sure, because that's what we see on the graph. Those are the x values which are reached. Do we include the minus 6 or do we exclude it? Do we include the 10 or do we exclude it? In other words, do you want one of these guys or do you want one of these guys? Yeah, the bracket, yeah, square bracket for that one, it's included. Open circle means not included, so like that. How about the range?
So since it's not going, since it's stopping from the same way.
So it starts at negative 2. It ends at, aha, yes, it ends at 3. Yeah, if you go to the other room, ask them for it. It's in the file cabinet.
And this one,
Right over there. Yep, they should help you with it.
and if I do that on my test, can I turn my review sheet in?
Oh, yeah, just turn in with the test. That's fine.
Okay.
Uh-huh. Let's see here. So, yeah, I was going to say, it's like I like to think about, when I think about range, I think about taking a horizontal line and just kind of like going up. And if my graph crosses that horizontal, intersects that horizontal line somewhere, well, that y is included, right? So yeah, 2 is included, not because that open circle, that's not what it is. Over here, there's a 2 in the graph, in the y, right? And then you keep going up, and there's always an intersection with the graph, right until you get to that top point. That's the highest thing in the range. The highest thing in the range is 3, which is included. And then past 3, you got nothing. So yeah, the range is minus 2 to 3 included. Yeah. So if you understand this example, you probably can do most of them. I'll do one more. Although this one's going to be kind of contentious with Stuart because it's going to involve some of them. They're unions. So let's see here. We can go minus 3 comma minus 4. Let's say. Well, no. Excuse me. Minus 4 minus 3. Right. And then let's see here. let's see here, and say that that point is, I don't know, 3, comma 1 maybe. All right, and then 3, comma minus 4, and then we go 5, comma minus 3, and this low point here we'll say is minus 0.2, comma minus 1. And again, we're looking at y equals f of x. So you guys tell me, what would the domain and range be for this thing? Two things with, oh, one of them's filled in though. See that? What is f of 3? F of 3 is what? Is f of 3 1? Or is f of 3 minus 4? Which one is it? The one that's filled in. That's right. So that's what that notation means. That's our way of saying that the value of the function is down here, not up here. Yeah, so that means f of 3 is minus 4 in this example. Mm-hmm. So to figure out what the domain is, you want to think about vertical lines. Right? We've got an x is mapping to minus 3 here. And there's always, see, wherever this vertical line goes, there's an intersection point with the graph. The whole way. So it's just minus 4 to what? And minus 4 to 5 included. What about the range? So what I was telling her is you got to look at horizontal lines to figure out the range. So like here, we got minus 4, right? And we keep getting stuff all the way up to minus 3. But then we got nothing for a little bit, right? So to start with, we got minus 4 to minus 3. Then there's a jump until you get up here to negative 1. And then, see, that 1 is fine though, see, because even though that 1 is not included there, it's included over here. And that's all we need is 1 point on the graph with that y for it to be in the range. You keep going up, and like all the way up to what in tarnation? Plus 3. Plus 3. Sorry about that. Otherwise, that's just nuts. So what did I say? Minus 1 included, right? To plus 3. Included. Did I do something wrong? Okay. Yep. Now, the other question, so up till now, we've sort of dodged the question of, for the most part, except for my cautionary dot diagram picture, we have pretty much been looking at things that are functions, right? But there are lots of things that you can draw the graph of that are not functions. So we can talk about what's called the vertical line test, right? So if you have y1 equals to f of x and you know x1, f of, let's say, x1, and y2 is equal to f of x1, where y1 is not equal to y2, you're in trouble. It's not a function, right? Because it wouldn't be single valued. And what would that mean on the graph? If you had a graph, right, and you had this point, x1 comma y1, right, and this other point down here, x1 comma y2, Same x value, different y values on the graph, right? I don't know what the graph looks like. It could be like this, whatever. The point is, when you take a vertical line and you look at its intersection with the graph, it crosses in more than one point. So this is failing. To fail the vertical line test means that when you look through a vertical line in your graph where they intersect in more than one point. So let's say it this way. The vertical line test, a graph passes the vertical line test if every vertical line intersects the graph at most one point. It's okay for it to not intersect the graph at any points, right? Like, see this one? Here we're looking at y equals like square root of x minus 1. All right? So I look at vertical lines, you know? No intersection, and then one intersection point. So it's a function, right? And a lot of times I draw the vertical lines like this, you know. Aha, good. One intersection point, one intersection point, one intersection point, right? But there's lots of things that aren't functions, right? Here's some examples. I mean, it's some graphs which are not functions. What example was I on? This was example 4? Yeah, you guys let me okay, well, anyway. My apologies if I've misnumbered. So if this is the graph you're looking at, so this would be, for example, the equation x squared plus y squared equals to, say, 4. That gives you a circle of radius 2, all right? And this fails the vertical line test, right? Because if you look at a vertical line, like this one, you cross here and here. So fails vertical line test. So graph is not the graph y equals f of x for a single choice of f. Now this one here, you can actually understand what's going on, and I think it's interesting to do this. So if we have x squared plus y squared equals to 4, right? We also have y squared is 4 minus x squared, right? And when you try to solve this for y, you take the square root of both sides, but you have to allow for plus or minus, we learn later. So that gives us plus or minus the square root of 4 minus x squared. So as you can see, two choices for our y. And what's going on, it's very simple to understand, actually. The top of the circle is the plus square root. See that? That's the graph of the y equals square root of 4 minus x squared. By the way, this part of the lecture is for your information. You're not expected to be able to reproduce this, of course, because you learn how to graph circles later in this course or the next, depending on how things structured here. And then the bottom one is minus the square root of 4 minus x squared. So the blue graph and the red graph, they're graphs of functions, because if you just look at the blue, the vertical lines only intersect with one point, right? Or if you just look at the red, it only intersects in one point. But you can't put them both together and get a function is the thing. So and there's other geometric shapes that you know and love, right? Like everybody loves triangles, right? Is a triangle the graph of a function? Like, no, it can't be, right? Because you're going to have to pass at least 2 points when you do vertical line, right? Now, there's also something called the horizontal line test, right? And you can draw a horizontal line through the graph of a function. That says something else about the function, but if a function, you know, doesn't pass the horizontal line test, that does not mean it's not a function. That's a discussion for another day, I suppose. I don't think that's in this section. Let me double check on that. So anything in the homework that was particularly troubling to you guys? You know, no struggle? I mean, we have not talked much about how to evaluate the formula for a function yet. That's like a lot of the homework is just like, here's a formula, plug in the number, right? So you guys got that? Like, you're like, that's... What I'm saying is, if I was to give you something like f of x equals to 3x minus x squared, and then I was to say, what's f of 0? What's f of 1? What's f of, what was that? Oh, yeah. F of 2. Like, you guys got, this is not, you're unfazed by these questions, right? These are like taking candy from the proverbial baby. Yeah? Yeah, just plug it in. Although, I think it should always be stated that taking candy from a baby is not actually easy. Have you ever tried to take candy from a baby? Unless they're sleeping, it's not easy. Same is true of small children. See here, 3. 3 minus 1, 2. This is very relaxing. Actually, I kind of like these. These are, I can do this all day long. Like this just fun. 6 minus 4, 2. All right. I did notice that there's one example. We should talk a little bit more about how to graph certain other examples. Like I think I missed. I know some of your homework has absolute value in it, like, right? So let's see here. What is it? What happened? What happened? Nothing? You know I'm easily distracted. Let's see here. Still wet outside, I guess. All right, so suppose you want to graph y equals to the absolute value of x plus 2, right? So what is absolute value of x? So we can make a table of values, right? We can be like minus x, and then, you know, y equal absolute value of x plus 2. And so, I don't know, you pick them, let's say minus, minus 2, minus 1, 0, 1, 2. That probably is good set. Should give us an idea what we're doing. So I plug in, absolute value of minus 2 is what? 2. 2 plus 2, I got myself a 4. Plug in minus 1, absolute value of minus 1 is 1. 1 plus 2, 3, right? Absolute value of 0 is 0. 0 plus 2, 2. Absolute value of 1 is 1. 1 plus 2, 3. Absolute value of 2 is 2. 2 plus 2, 4. All right, so now we can draw the graph. We've got, let's see here. Suppose that I should have made it bigger. Oh well. So it's minus 2, 2, 1. So what do I got? I've got the point 0, 2 is in the graph, right? That's here. Let's see here. Minus 1, 3. Here-ish. 1, 3. It's over here, right? Minus 2, 4. It's like here, and 2, 4 over here. What do we got? If I could draw it worth anything. It's a V, is what it is, if I did it right, carefully. It's a V, and like the smallest it gets is at the y-axis where it intersects. So this is y equals absolute value of x plus 2. Now that we're in section 2. So this was a graphing problem that was covered in section 2.1, right? Now we can ask an additional question. If we think of this as the graph of a function, is that possible for one thing? Does this satisfy the vertical line test? Well, sure, right? You could think about vertical lines going through it, only one point intersection. And, I really should draw some arrows here or something. It goes on and on, yeah? What's the domain? If I call this thing f of x, give it a name, yeah? You guys tell me, what's the domain? What's the range? Like, is there any x, put it a different way, is there any choice of x that we can make that breaks the formula? Like, there's not, right? Like, absolute value of anything makes sense. And so that's fine. The formula makes sense for all x, so the domain is just all real numbers. So you can write it like this. You don't like that notation, so you could use this. It's also good. Real number system. How about the range? What's the range? Mm-hmm. So you got the infinity up top. And this is at 2, right? So we go 2 included to infinity, just like that. That would be the range. So, yeah, these aren't bad. Like domain and range, once you understand, domain goes with x, range goes with y, right? So the domain is the x values which are reached by the graph. The range is the y values which the graph actually attains, right? And that's it. And if we're given a picture, it's only a function if it passes the vertical line test, right? Now this last example actually fails that horizontal line test I was talking about, because if you take a horizontal line like this, you see it intersects that graph in 2 points, but that doesn't make it not a function. It just means it's not what's called a one-to-one function. But I don't know if we ever talk about that in this course, and at least not right away anyway. Maybe later in this chapter. If I could remember what's in which chapter, I would be doing much better in here. I don't know why I'm asking you guys. I know you guys already told me you don't read the book. Wait a minute. Did you guys tell me you don't read the book? I have to do homework. You just do the homework? You don't look at the book? It's hard to look at because online. I like that answer. That's a good answer. Well, anyway, that's it for today. I have a exciting math meeting I need to go to now, so you guys get out a little bit early. So enjoy the rain, I guess.